want us to assume. I wouldn't want us to assume, you understand? I would love us to start everything from the scratch so that there will be no assumption, so that everybody will be carried along. That is the essence. We're actually not doing this class in preparation for exams, so we don't have a timeline. The only thing is we should try as much as possible to avail ourselves on Sundays from 3 to 4, you understand? It's a 1-hour interactive session. I call it an interactive session because everybody is going to contribute, you understand? So we are going to be talking about the basic components today. We'll be looking, these are the things I want us to talk about. We're going to be talking about basic components of the inverter solar power system. We're going to be talking of radiation of the sun at various locations, you understand? Radiation of the sun power at various locations. We're going to also be talking about steps in solar inverter system installation. Then we are looking at what? System sizing. If you look at these things, they all have what do we call those ones? Sub items under them. If you look at the basic components of the solar inverter system, solar power system, we have the inverter, we have the battery, we have the solar charge controller and the solar panels, the cables, you understand? Each of these components has its own role, you understand, or its own function or her function. So I would love us to please, if there's anybody that can tell us what he understands about the inverter system in the solar power system, what does the inverter does? Anybody? Hello?
Hello, let me try.
Okay.
Yeah, I would say the inverter is it helps in converting direct current rather to alternative current.
Okay, that's fine. That's fine. That's fine. Yeah, direct current to alternating current. Okay. Any other contribution? It's fine. It's actually good. That is good. It actually converts direct current to alternating current, you understand? So why do we convert this alternating current to DC current, direct current to DC current? Energy can be generated by photovoltaic cells, that's our PV, our solar panels in the form of DC, that's direct current, and also can be stored in our batteries in the form of direct current, you understand? So this power generated in direct current, you find out that it's actually not useful because our gadgets and our everything actually uses the alternating current. So this inverter system is what will convert it from the alternating current to what? To the direct current so that our appliances can make use of it. I hope I'm making sense. Any objection?
I just came out back. Oh, the system logged me out.
Okay, sorry. So were you with us when we started talking about these basic components of the inverter system? Are you with us? Okay, anyway, if you miss out
Yes, I'm here.
yeah, if you miss out any part of it, I think it's actually been recorded, so you can actually, I will share it on our Google Drive, you understand? I will get your Gmail address and share it on the Google Drive, on the Google spreadsheet, on the Google Drive, you understand, so that you can access it. So,
It's okay.
but basically what we were actually talking about is we were talking about the basic components of the inverter solar system. We talked about the inverter. Somebody gave us a definition of inverter or what he knows about inverter as what converts direct current to alternating current, you understand? So I now went further to add it that, okay, why do we have to convert the direct current to alternating current? Because our photovoltaic cells, that's our solar panels, PVs, actually generate power in the form of DC. Our storage device actually store current in the form of DC. So this DC is actually not useful to our gadgets because our gadgets actually are driven by alternating current, you understand? So this alternating current is what we need, but actually we have this DC stored. So the inverter system actually converts it from the direct current to the alternating current. But in some systems where you don't actually, if the system you're designing actually can work with DC, I believe there may be or there will be no need for you to actually require the inverter. You can just use the alternative, the generated power or stored power in direct current form to power that system directly. So that is that. So our batteries, I think we'll need to, I will hasten this part of it, you understand, so that because I think most of us are familiar with this ones. The battery, as we all know, are our bank. That is what stores energy. Understand? It stores our energy so that when we need it, we can actually pull out from the bank. It's just like saving your money in the bank. When you need it, you pull it out to use it. You understand? That's the same thing. So, and you also save it there and pull it out when you need it. The same thing applies to the battery. Energy generated either from our grid, which is NEPA, can be stored in the batteries, or from solar PVs can be stored on the batteries and then later usage, or it can be later retrieved for usage. So the next thing we're going to be, next component there is the solar charge controller, you understand. The solar charge controller is actually, as the name implies, it's a charge controller. It's a solar charge and a controller. So it actually regulates the quantum of charge generated from the solar that goes into the battery, you understand? So this particular controller is an important component of the solar power system, in the sense that it protects the battery, you understand? It protects the battery. So that is what actually protects the battery, so that the lifespan of the battery will actually be utilized. That's the design lifespan of the battery will be properly utilized. Then the next thing is the solar panels, or the PV. PV stands for photovoltaic cells. PV cells or solar PV, or in some, wherever you see PV, they were all talking of solar panels, you understand? So these 4 solar panels are another component of the solar power system that generates power when light of a required wavelength falls on it, you understand? Mind you, the light has to be of a required wavelength, you understand? These materials generate charges only when light of required wavelength fall on them. So please, we should be mindful. I know why I'm saying so, you understand? Because I have heard questions from some people that say that there are some solar, there are some this that do this, there are some, why is it that ladies cannot do that, you understand? Why is it that moonlight cannot power the solar since it's light? Or why is it that our lights can, you understand? So the fact remains, light that falls on these solar panels have to be of a required wavelength, you understand? We'll come to that, you understand, in details much later. Cables, you understand? Cables are interconnection devices between one component to the other. Between the solar panels, inverter, to the charge controller, you all need cables to connect them, you know, to link them together. So they're actually interconnecting devices. It's an interconnective, they are interconnecting medium, you understand? So I hope we're making points, or we're making progress. I hope we're making points, or we're making progress. Any objection, any question, any addition? You know, it's a collaborative class. It's a class where everybody must what? Contribute. I believe in that. Everybody must contribute, because if everybody contributes, your experience may not be the same as mine. Musti, can you hear me? I can see you. I don't know whether you're here. Hello? Hello, can you hear me? Can you all hear me?
Yes, we can hear you.
Okay, that's lovely. That's lovely. My Oga, I hear.
Loud and clear.
Thank you. So I think is there any question, any addition, please, on this part that we've just discussed, basic components of the inverter solar power system? Is there any question?
I guess we are good.
Okay,
Can
that's fine.
proceed.
That's fine. So the next thing I would like us to talk about is radiation of some.
Please,
Okay.
there's something I want to ask concerning batteries.
Okay.
You know, yeah, in my place of work, when I went, we opened our battery cabinet
Hmm.
that power the turbine system.
Hmm.
So there is something I observe about the battery. There are battery that uses what do I call it? Electrolyte.
Okay.
It can be refilled. But
Yes.
these batteries, they are not that the voltage they are reading to 2 volt, but they are giving about 75 ampere per hour. How are they able to achieve that with small voltage but higher ampere rating?
Yeah, it all depends on, from my basic knowledge, you understand, it all depends on how you design it, you understand. It all depends on how you design. These batteries, if you look at batteries, if you look at the way batteries are, they are combinations of cells, a combination of cells, you understand. If you have one, two, three, four, five cells at uh, at 1 volt. Let's say we have each cell has 1 volt. By the time we arrange them in series, you understand, we can actually achieve up to 10 volts, right? Series connection of individual cells. If you open a battery, I don't know whether you've had the opportunity to open battery, you find out that there are partitions. Each partition is a cell, you understand? And those partitions actually have EMF that are actually of small values. But by the time you link them up all together, they produce a large EMF. I don't know if you are with me, Hela. Hello. So let me just, since we are recording it, you understand, maybe he's having connection issue and since it's going to be recorded, maybe he will now, and he can actually later use the video to get his point. So, but what we are trying to say is, if you open a battery, I have had the opportunity of opening a battery. You see small cells, whether dry cell or wet cell, you understand. You find out that they're actually small partitions. So by the time, and most of those partitions are connected in series. For those of us that did elementary physics, and you understand, you will know that when you connect cells in series, you have a larger EMF. And that is the same thing we actually do by the time when we want to connect a 48-volt system, you understand. When you connect 12 volts, 12 volts, 12 volts in series in 4 places, you get a 48-volt system. But by the time you say you want to build a 12-volt system, you understand, that has a lot of ampere hour, you just parallel them. By the time you parallel the four, you will have the same 12 volts, but 200 ampere hour in 4 places, which makes it 800 ampere hour. So the same thing, I think if you want to achieve high current, low voltage, you could easily parallel those cells. And if you want to achieve a higher voltage, you could just series those cells, depending on what you want. But one thing I want Hela to know is that he should know that if you have a larger ampere hour at a lower voltage, it actually gives a very good backup. You understand? It actually gives a very good backup because the ampere hour has actually increased. So those types of battery he's talking about, I have even seen the one that is 2 volt 1000 Ah. I think we've used it on Huawei projects for telecom sites. Those types of batteries are used as hybrid batteries for telecom sites, where you see 2 volts 1000 ampere hour. They will now be assembled in to 48-volt system, since in the telecom sector we use 48-volt system to transfer to power our devices. So by the time you achieve a 48-volt system, you will know 48-volt system at 1,000 ampere hour. By the time you multiply it, you see that the kilowatt hour you're having from such setup will be very high. Those batteries are very good for backup. So in the telecom sectors, in the telecom sites, there are hybrid sites where diesel wants to be conserved. So when these generators run for a particular time, they charge the battery and shut down. And when they shut down, those batteries will now take over, generator rests, then solar, and then the battery will now power the site for a period of time. When the battery reaches a particular level, the generator will start automatically. So these things are actually they are not too complicated like that. They are just simply arrangement of cells to achieve either high voltage or high current, depending on how you want it. You understand? So I don't know. Hela, are you clear? If he's still here, or if he's not here, because I can hardly hear him, I can barely hear him. So I think it's good that we go to, although the meeting is saying about to end, because we're actually using a free version for now. I would love us to, in the near future, when we start making headway on this this thing, we should be able to start using the unlimited version, you understand? So that by the time we start using the
I'm
unlimited,
hearing you loud and clear.
okay, does that explain your own your question?
Yes, I got it. As when you say parallel, everything came back. I just
Okay, that's
grabs
lovely.
everything.
That's lovely. That's lovely. So good to hear that. So now the
Yeah,
next the
thank
next
you.
thing I would want us to discuss about is please, if the meeting ends, I will still restart the meeting so you can join with the, you understand, you can join back with the previous link. I don't need to share another link. Are you with me? Okay. If the meeting ends, you can
Yes, sir. We are
okay, I will. Let me just. You can once the meeting ends, you can just join with the previous link so that we can complete the remaining 30 minutes. It's actually a 1 hour class. You understand? So now the next thing I would want us to do is I would want us to talk about something else. Let me stop sharing this. The next thing we're going to be talking about is, okay, let me see. The next thing, if you look at this slide, if you look at this page, sorry, you see that the next thing I want us to talk about is radiation of sun power at various locations. So what comes to your mind? You see, discuss the global solar, how it affects determine solar capacity. Fine. I would want us to look at something here, my dear brothers, before this thing logs us out. I want us to look at something here. Okay, stop sharing this screen. Then I will now share another screen. I will share another screen. Okay, please, let's look at this. Let's look at this map very, very well. Let's look at this map. I'm coming. Let's look at this map very, very well. If you look at this map, are you with me? Can you see the map? I took Nigeria as a point of reference. You understand? Can you see this map?
yes, we can see the map. It's
Okay.
clear. Maiduguri is red.
Aha. So you can see Maiduguri is red. You can see Kaduna, the middle belt. You can see how the radiation it keeps coming down, 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 down. You understand? Till you understand. So now, what can you deduce from this map? This is PV power potential. You understand? PV power potential for various regions across the country. We're only talking about Nigeria because Nigeria is where we go and work. You understand? For now, you understand? I don't know because I know very soon some of us will be going global, international. So, but I know for now, let's use Nigeria as a case study because most of us, our works are localized here in Nigeria. So look at Nigeria now. If you look at Nigeria very well, you see that God decided to share these things unevenly. You understand? Let me use the word unevenly. God, in his own wisdom and his own infinite wisdom, decided to share this thing unevenly. You understand? But it does not restrict you from harnessing the sun. The only thing is that in Maiduguri, you understand, if you look down, I don't know if you look down here, there is something here that says daily totals. You understand? Let's look at these daily totals. Kilowatt hour per kilowatt power. You understand my point? Kilowatt hour per kilowatt power. So this one is 1 kilowatt hour, what 1 kilowatt hour of solar capacity will generate for you I don't know if you are seeing, are you seeing the colors all together? Are you seeing the different colors on this particular point, this particular line that is here?
Yes, we
This
are
part,
seeing the colors.
okay. If you
I
look
can see
at,
that.
you can see 3.2, 3.6, 4.0, 4.4, 4.8. What it actually means here is if you have a kilowatt hour, a kilowatt of power, that's 1 kilowatt of solar power. You understand? If you have a 1 kilowatt solar power system, what you can generate in areas that have this green. Are you seeing the green area at the coastal areas, you understand, that have green? The green is not much in Nigeria. You can harness up to 3.2 kilowatt hour with 1 kilowatt of solar panel in one day. It's a daily output, you understand? I don't know if you get it. Or I would love us to continue on the next this thing so that I want you to understand this thing. It's very, very good to understand this before you understand, because that's where a lot of the mistakes lie, especially when it comes to project implementation. So we will be logging out and joining anytime soon.